All right, so this lesson is on trigonometric ratios. And the key takeaway here is that angles and side lengths in right triangles are related. Okay, so we're starting to investigate the relationship between the angles in a triangle and the sides. So previously we've only looked at the sides by themselves or angles by themselves. Now we're looking at how they're related together. Okay, and I want to return to this idea from the beginning of the unit of like standing downtown and looking up towards the top of a tall building. Okay, so you can imagine yourself doing that, and you'd have to tilt your head, right? And the angle at which you'd have to tilt your head is related to how tall the building is, right? So imagine you're looking up at the Sears Tower. You have to tilt your head way, way back to see the top of the Sears Tower if you're close to it downtown, right? Whereas if you're looking at your house, don't have to tilt your head quite so far, right? So in my picture, if the height of the building is x, and this angle here, the angle that I'm looking at, we're going to call that theta. Theta is just a Greek letter. You're at the stage in your math career where Greek letters pop up sometimes. Theta is like an x we use for unknown angles. Okay, so there is a way I can write down a relationship between this angle and this height, and that's what we're interested in this lesson here today. Okay, this lesson is very much going to be just about the basics. You're sort of learning the vocabulary here, and then we're going to get to more interesting applications as we go on. Okay, so it is super crucial that you have this in your notes. We're going to use this for the next like 10 lessons in a row. So make sure at some point you pause the video and copy this down. These are our new terms, our new vocabulary terms that I said we were going to get into. So there are 3 different relationships in the triangle. Sort of makes sense. 3 angles, 3 sides, 3 relationships we're going to look at. They are pronounced sine, cosine, and tangent, and then they're often abbreviated. So sine is written S-I-N. If you say sin A instead of sine A, it's like one of those things that kind of hurts a math teacher's soul. So you'd read this as sine of A, cosine of A, tangent of A. Okay, so where you're standing in the triangle determines which relationship you're using. Okay, so if we're looking at A, notice the different relationships of A, like sine of A involves the red side, the opposite side, and the hypotenuse, right? Whereas let's say I was standing on top of the building and looking down, notice like I would need a different relationship to compare that red side to the hypotenuse. Okay. Make sure you have this in your notes, and then we're going to look to apply it. All we're doing now is figuring out which relationship, or like for an angle, figuring out how to write down a given relationship. Okay, so you should have that entire last page in your notes now. We're going to look at a couple of problems. So we'll do one example of each type of ratio. So this one says in triangle QRS, the measure of S is 90 degrees, and then it gives us some side lengths. So QS, RQ, and SR. What is the value of sine of R? So I'm going to underline that. And it is super crucial that you draw these. You are not going to be able to get them right without drawing them, at least not consistently. So I'm going to draw a right triangle for every single one of these. And notice it says S is 90 degrees. So S has to be my right angle. So you need to label your drawing based on what's given in the text. R and Q, it doesn't matter so much which order I put them in, but then I have to label my signs consistently. So I'll put R down here, Q up here. Okay, so we have SR is 11 units, RQ 61 units, QS 60 units. Okay, and then I'm going to highlight the angle I'm looking at. So R is the angle I'm after, and I want sine of R. So I'm going to write that down, sine of R. And then I'm going to go to my notes, which I've reproduced here. sine of r is the opposite side over the hypotenuse. Okay. So notice in the example, opposite is through the triangle to the opposite side. Now my triangle is inverted, but I still need to go across to that opposite side across from it. Okay, so in this case it's going to be 60 is my opposite side. Let's actually label that. So opposite, and then over, well, it's opposite over hypotenuse. Hypotenuse is the easy one because it's always the biggest side, so 60 over 61. Okay, so 60 is my opposite side. This is my hypotenuse. So all I'm doing is writing down the correct sides in a ratio based on the model that I gave you. And it may take some practice to see it correctly every single time. You need to be drawing them in order to figure these out. Okay, so 60 over 61, it says to the nearest hundredth, that's 2 decimal places. So I'm going to put that in my calculator and round it, and I get 0.98 is sine of r. Okay, let's look at another one. Make sure you pause and get this in your notes if you have not already. Okay, here we have triangle ABC, and we're given C is the right angle, and then a bunch of measurements, so I need an A and a B. I'm going to put A up here. It does not matter as long as you label your sides consistently. So from C to B is 35 units, it says. From A to C is 12 units, and from B to A is 37 units. And we want this time the cosine of A. So I'm going to highlight A, and we'll look at our notes again. So cosine of A, it says, in this case was B over hypotenuse, so adjacent over hypotenuse. So here, cosine of A in my example is going to be, adjacent means next to. So remember in the sine example, we went across to the 35. Adjacent is going to be the side it's touching. So 12 is my adjacent side. And then hypotenuse again is the longest side, 12 over 37. And in this case, it does not ask us to round, so we're just going to leave it as a fraction. So that's going to be my final answer there. Okay, again, make sure you have this example in your notes. Notice it doesn't matter which angle I pick. So I can do the top angle or the bottom angle as long as I'm looking at the correct side. So I'm looking at the adjacent side. If I was looking at B, the adjacent side would be 35. Okay, here we have triangle stew, which is cute. Measure of angle U is 90 degrees. And then TS is 41, UT is 40, SU is 9. We want the value of the tangent of S. So S is here. And looking, I see tangent is opposite over adjacent. Okay. You should be getting the hang of this by now, hopefully. Pause, think about this one for a second, and take a guess what this should be. So tangent of S is going to be the opposite side. So the opposite side is 40 because we're going across the triangle. 40 on top over 9 is the adjacent side. Hopefully you got that one correct. If not, feel free to rewind and rewatch, or just try a couple. It's okay to get them wrong. Okay. So those are your 3 examples. Again, it's crucial to have good notes here as a reference. This is not that hard. We're just reading values off the triangle, but you're going to be lost if you don't have anything to reference as you click through them. Okay, and then I want to leave you with just one more example here. And here what I've done is I've taken our angle Z here, and I found all 3 trig ratios for angle Z. So hopefully this will help you see the difference between each of the 3. The best way to learn this is through trial and error using a reference. So make sure you have good notes and then jump into the practice problems is what I encourage you to do.